Welcome to another video, and this time we're talking about inverse functions. We're going to start this video by talking about a few definitions. If you look on your screen right now, you have two mappings. Mappings, if you remember from the video talking about domain, we talked about mappings. So in a mapping, like the left-hand side. The left-hand side would be the domain and the right-hand side would be the range. So if you look over here on the left-hand side, let's look at this mapping over here. What I have is a set of students on your left-hand side, and they are mapped to a grade on the right-hand side. So I have Eve, Asia, Dougie, and Ian. And then I have the arrow pointing at what grade they made. So Eve made a D, Asia made an A, Dougie made a C, and Ian made a B. Now, the unique thing about this mapping right here is that it's 1-to-1. What does 1-to-1 mean? So you probably never heard that phrase before, but what it means is that everybody in the class has a unique grade. And what I mean by unique is that there's no two students in this class that have the same grade. Okay? If you look on the right-hand side over here and look at this mapping, I have the same students, the same grades, but Asia and Dougie made the same grade. So this is not considered to be 1-to-1. Okay? 1-to-1 means every domain has a unique range. Okay, no two students can have the same grade. So this is not 1-to-1. Okay, another thing that I want to point out about these two mappings is that the one on the left hand side, this one right here, is, let me make this red. So this one on the left hand side, this one is considered to be on2. Okay, this function is also on2. And the best way to describe on2 is that there are no unused ranges. Okay, in other words, for this particular situation, there are no grades not being used. That's what on2 means. So all the grades, A, B, C, D, all of them are being used. But if you look at the right-hand side, if this mapping over here on the right-hand side, this is not considered to be on2 because the grade of a D was not given to any of the students, which is a good thing, right? So this one is not on2 and it's not 1-to-1. The one on the left-hand side is 1-to-1 and it's on2. So it's important that we talk about this because in order to find an inverse, a function needs to be 1-to-1 and on2. Okay, and you'll see why in just a minute. Another thing, and you may see a couple of questions like this in MyMathLab, but if I give you a graph, so here I have two graphs, and I'm going to erase this part up here because this is not part of what I need. Erase this. So if I give you a graph, okay, first of all, both of these graphs are functions because they pass the vertical line test. You know, functions, if they pass the vertical line test, meaning if you have a vertical line, it can go from left to right, then if the graph touches in one place on that vertical line, you say that it's a function. Both of these are functions. But to tell whether it is a 1-to-1 function, you have to do a horizontal line test. So if I did a horizontal line test, that means I'm taking a horizontal line. Let's say this is my horizontal line, and I'm going up and down this graph. If this graph crosses in more than one place on that horizontal line, then it's not 1-to-1. So right here, obviously, if I took that red line and I went up and down, it's going to touch in two places everywhere, basically. Almost everywhere except for the vertex. So this one is not 1-to-1 because it doesn't pass the horizontal line test. But if I did a horizontal line test with this graph, of course, if I go up and down on this graph, it's only going to touch in one place everywhere. So this one is considered to be 1-to-1. 1-to-1 means that you can actually find an inverse of that one. If it's not 1-to-1, that means you have to either restrict it in some kind of way in order to find the inverse. And that's the only way that you can do that. So what we are doing in this video is, now that we got the definitions out of the way, we want to talk about exactly what a function is, or inverse is. So let's say if I have a function, and all the functions that I'm going to give you in this section will basically be 1-to-1 and onto if I'm asking you to find the inverse, okay? So I'm going to start real simple, okay? This right here, if you were to graph this, this will be a line, y equals mx plus b. It'll be a line, and you know a line is 1-to-1, it is onto, so I can't find the inverse of it. So if I want to find the inverse of this function, the definition of an inverse, and I'll kind of pop this up on the screen right now. The definition of an inverse says if you have a function that is 1-to-1 and onto, then for every x that is mapped to a y, the inverse will be flipping those two things, and the y will be mapped to the x. So if I think about those mappings, let me go. I hate to go back, but let's go back. So this one right here, we know for sure that this one is 1-to-1 and onto, right? So if I was to switch the x and y, because right now the x's are the students and the y is the grades. If I was to switch this, and I'm going to do this real quick. If I was to switch this and say, okay, I'm going to put my grades over here, and I'm going to put my students over here. Eve, Asia, Dougie, Ian. Okay, so I have my grades that are now my domain, and I have my students that are now my range, and the inverse is basically just switching everything, right? So I got to think, okay, who had an A? Asia had an A. So in my inverse, A is going to be mapped to Asia. Who had a B? Ian, sorry. So B is going to be mapped to Ian. Who had a C? Dougie. And then who had a grade of a D? Eve. So this right here is considered to be an inverse. And the inverse notation is going to look like f to the -1, but that's not how you say it. It's f inverse of x, okay? So that's the notation for inverse, f inverse of x. It looks like this. This mapping right here is considered to be the inverse. The original one is just f of x. When I switch the x and y, that creates my inverse. Okay, so now with all that being said, let's go back to the problem that I had written out here. Let's say the problem wants you to find the inverse of this function. So let's talk about some steps that we need to do here. It's actually 4 simple steps. The first thing that we want to do is we want to replace, and I'll kind of write them out now. Replace f of x with the y, okay? You want to replace f of x with the y. So for this problem, I'm going to put y, and actually I'm going to write this in black. I don't think it matters, but okay, I replace f of x with the y. Step 2, switch x and y. So that's what an inverse is, right? An inverse is when you switch your x and y. So we're about to create an inverse just by switching the x and y. So wherever I see y, I'm going to put x. And wherever I see x, I'm going to put y. So I just switched the x and y for this problem. Now, the notation is not correct right now. Okay, so step 3, what I need to do now is I need to solve for y. I need to get y on one side by itself. Do whatever you have to do to this particular problem to get y by itself. Now, in order to do that, let's slide this up a little bit. So I have, let me write the problem down. And your goal is to get y by itself. So let's move the 5. X minus 5 is equal to 7x. And I have to get y by itself. So in order to do that, I have to divide by 7. And that means divide everything by 7. Okay? So I end up getting x minus 5 over 7 is equal to y. I have the y by itself. So I've done step number 3. And basically you're done, because the last step is just to put the notation in there. So step 4 is to replace the y with the inverse notation. That's f inverse of x. Okay. So for the problem that we have, in place of, right here is where I have the y, I'm going to put f inverse there. So this is going to be, let's do in black, f inverse. I'm going to write this with the f inverse being on the left hand side. And this is basically your answer right here. This is the inverse of the original problem. So look at these 4 steps. Okay. Step 1, replace f of x with a y. Step 2, switch your x and y. Step 3, solve for y. And step 4, once you solve for y, replace it with the f inverse. And those are all the steps you have to remember. Now, the thing that they're going to do is make the functions more complicated. The steps don't change. It's just the function changes, and the function can be more complicated than before. Okay, so let's keep these steps in mind. Replace f of x with a y, switch your x and y, solve for y, and replace y with the f inverse. Okay, let's see another example. Let's see. Okay, let's say I have this problem. And let's go through our steps. The steps are exactly the same, okay? Step 1, we are going to replace the f of x with a y. Step 1 done. Step 2, you're going to switch your x and y. Wherever you see y, you put x. Wherever you see x, you put y. So instead of it being x to the 3rd power, now it's y to the 3rd power. So no surprises here. I'm just switching my x and y. Now, step 3, I need to find a way to get y on one side by itself. Got to find a way to get y by itself. So I'm going to rewrite the problem and do whatever I got to do to get y by itself. The first thing I'm going to do is move this 2. The 2 needs to go to the other side. So that's going to give me x plus 2 is equal to 7y to the 3rd. Then I have to divide by 7. Divide by 7. And that's going to give me x plus 2 divided by 7 is equal to y to the third. And we're trying to get y by itself. We got y to the third. I just need y. So if you have y to the third power, if you're trying to get rid of the third power, you got to think, what's the opposite of taking something to the third power? It's the cube rooted. So in order to get rid of that cube, I'm going to build a cube root house over the y to the third. Now, if I do that to the right-hand side, I have to do the same thing to the left-hand side, right? So I build a house over here, got to build a house over there. So now I have, finally, I have x, oh no, I have cube root. Cube root x plus 2 over 7 is now equal to y. I have y by itself, finally. Now, step 4, I'm going to put the F inverse notation. And this is your answer. Okay. So there's the full problem. Let's look at another example. I'm trying to think of something. Let's go backwards. How about yeah, let's go backwards. So I need to find the inverse of this, right? So step 1, I have to replace my f of x with a y. Step 2, step 2 is to switch the x and y. So wherever I see y, I put a x. Wherever I see x, I put a y. And I get this. Now, step 3, I have to find some kind of way to get y by itself. And here's where I'm starting out. I got to get y by itself, but y is inside of a radical. I can't take anything out of the radical until the radical goes away. The little house, it has to go away. So I have a cube root house. In order to do or to get rid of a cube root house, you have to cube it. So you always got to think about what's the opposite, right? If I raise all of this to the third power, it's going to make the little house go away. They're going to cancel each other out. But if I do that to one side, I have to do it to the other side. You got to think about what's the opposite. So this will be x to the third is equal to 7y plus 5. I'm still trying to get y by itself. So now subtract the 5. And lastly, to get y by itself, divide by 7. And you get x to the third minus 5 over 7 is equal to y. So I got y by itself finally. And the last thing I got to do here is to put the notation in place. So I'll put f inverse and x to the third minus 5 over 7. And this is your inverse. Okay, now I want to do an example that has fractions in it. Let me zoom this out so you can see the whole thing. I'm trying to make sure you can see the whole problem before I move on. Okay, now one more example I want to do with fractions. I probably should do 2 more examples that have fractions. We'll see. Okay. I'm making up stuff off the top of my head. Yeah, I'll do 2. I'll do this example and I do one more that has 2 x's in it because you need to see the difference between those two. So step 1, replace f of x with a y. Step 2, switch the x and y. Switch the x and y. So x is equal to 3y minus 7. I just put x wherever the y was and y wherever the x was. Switch the x and y. Now I have to get y by itself. Now, oops. Sorry, I had something on my phone. So in order to get y by itself, I have this fraction, y'all. So I have this fraction and you have to get rid of the fraction. We've talked about this in a couple of different videos, but I'm not sure if you remember. So let me just review it real quick. So in order to get rid of the fraction, I have to multiply both sides by the LCD. So if you remember in previous lessons that we've done, if we want to get rid of the fraction, we will multiply by the LCD. The LCD in this case will be 3y minus 7. And you have to multiply both sides because notice I put brackets around the whole thing, right? So if I multiply x times 3y minus 7, I'll have to distribute there, right? And then on the right-hand side, when I multiply by the LCD, the denominator just cancels out with the top. So it kind of does this. And you're just left with 5. So that's what I get right there. But now I have to distribute this x. And you don't have to distribute, but most students that I see working these problems out, that's just the first thing they do. They're like, oh, I'm gonna get rid of the parenthesis by distributing the x, and you get this. Now you have to solve for y. Remember, your end game is to solve for y. So now I need to move the 7x. So I'm gonna move the 7x to the other side. And you could put the 5 first, that's fine. You could have put 5 plus 7x, but I usually put the variable term first. And now I have to solve for y. The one thing that's in the way of y being by itself is the 3x. So I will divide both sides by 3x. That's going to make this go away. So y is equal to 7x plus 5 over 3x. So I finally have the y by itself. And oh, I didn't write the step 3. So I switched x and y for step 2. And then I just went ahead and did step 3, which is solve for y. I was like, what number am I on? Okay, so, and then lastly, step 4 is to replace the y with the inverse notation. And this is your answer. Okay, I'm telling you, these 4 steps stay exactly the same. It's just solving for y is going to change depending on what the function looks like. I'm going to do one more example because I don't want this video to be too long. I'll do one more example. And I want to do one that has two terms at the top and bottom, or two variables, or not two variables, but two x values in the fraction form, because I think this goes a little bit different than the previous one. But let's do step one, and that is replace the f of x with a y. Okay. Now step two, you switch your x and y. So wherever you see y, you put an x. Wherever you see x, you put a y. And you see an x in two different places. So I put a y in two different places. Now step three is to solve for y. So in order to start that process, we have to get rid of this fraction. Let's start out by doing that. In order to get rid of the fraction, you multiply by the LCD. The LCD in this case will be 2y minus 7. So I multiply 2y minus 7 to both sides. So on the left-hand side, this will be x 2y minus 7. And then on the right-hand side, this crosses out. You'll get y plus 3. Now, if I distribute, which is what most students will do, they will distribute this x and you get to this point right here. Now notice, you're trying to solve for y, but there's a y on both sides. This is a unique situation here. I need to solve for y, but there's two y's. So you have to find a way to get these y's together. So this is what you need to do. You need to get every term that has a y in it on one side by itself, and anything that doesn't have a y needs to go on the other side. So on this particular problem, I'm going to do something. I'm going to bring everything that has a y on it, which is these two terms right here. If it has a y on it, I'm going to move them so they're both on the same side. So I'm going to move the y to the other side. I get 2xy minus y. Now, anything that doesn't have a y on it, I'll do this in red, like this one and this one, those two do not have a y on it. They need to go on the other side. So I'm going to move this 7x to the other side. So I end up getting equals 7x plus 3. So notice what I did. I got the two terms that have a y on one side, and I have the two terms that don't have a y on the other side. Now, the reason why I'm doing that is because now if you look at the left-hand side where you have the two terms that have a y in them, they're on one side, what you can do now to make this just one y is to factor out a GCF. Look on the left-hand side, and if I ask you what is the GCF, you would say, oh, the GCF is y. Okay, the GCF is y, so we're going to factor that out. Like I said, it's kind of like you're looking for a GCF, right? If you look for a GCF there, the thing that they have in common is a y, so I factored a y out, and now look at the problem. You just have one y now. And that was the whole reason why you wanted both of the y's to be on one side, so you can factor it out, and now you just have one y. One more step, because we do need that y to be by itself. So in order to get the y by itself, I'm going to make one more move, and that is to divide by this stuff in the parentheses, which is the 2x minus 1. So y is equal to 7x plus 3 over 2x minus 1. So finally, I have my inverse. I'm going to now put the inverse notation, and I'm going to celebrate. Here is my answer. In this type of problem, this last example I just did is probably the most complicated one you'll see in this section, okay? Where they have a fraction and they have the two variables on the top and bottom, it's a little bit more complicated than the traditional ones. So I hope this has been helpful. I'm trying to think of anything else I want to talk about. Another thing, just real quick, I want to point out that if you have an inverse, if you have a function and it's inverse, the unique thing about graphing them, I want to make one little comment about graphing. If you are to graph a x, f of x, and its inverse, if you were to graph these two things, a function and the inverse of that same function, the unique thing about graphing those two things is that it's going to reflect on the y equals x line. It's always going to reflect on the y equals x line. So let me show you what I mean by that. First of all, do you know what y equals x? The y equals x line is the line that goes right here through the middle like this. This right here is called y equals x, okay? So what they're saying is that if you took a graph and its inverse, it should reflect across that line. You should be able to fold it and it'll be right there on that line. So if you had a graph that looked like this, I'm just going to make up something. Let's say I had a graph that did this. Yep. If I had a graph that did that, and you'll actually see this in probably the next video, this is called an exponential function, then its inverse is going to be somewhere down here. Okay. These are inverses of each other, and this right here is actually called and this is not to scale. Actually, I ought to draw this a little bit better, because any math people will look at this and be like, that is not the scale. Okay. And there's some people looking at that like there's not even really a difference, but it's a little bit of a difference there. But this right here is called a logarithmic function, and you'll learn that later on also. But these are actually inverses of each other because they actually fold across that y equals x line. So anytime you have a function and its inverse, it's always going to reflect on that y equals x line. So any of the examples that we did in this video, if you take the original function and the inverse that you found at the end and put them both in a graphing calculator, you'll see that they reflect on that y equals x. All of them should do that. I hope this has been helpful. I'll see you next time.